Alright guys, so I'm gonna repost the video that we had seen today. So first off here we're gonna deal with the arc or the inverse trig equation, trig graphs. And so the original sine one looks like this, the original cosine one, and the original tan look like this. Okay, and so there's a couple of clues that we can do with here so that we can mess around with these equations. So here, this is arc sine, and remember that I can write it as arc sine or sine to the -1. Okay, it means the same thing. So I'm going to reorder this. So I'm going to write it 3 sine -1. I'm going to take out the 2 here, so I'm left with x, and if I take out a 2 from here, I'm left with 1. I'm going to take out a 2 from here, it is 1/2 plus pi over 2. So I'm just rewriting the equation again. There's a couple tricks here so that you can really tell what the answer is, like if they give you a graph and an equation, or vice versa, how I can tell what's going on. So first you need to know what the originals look like, so just pay attention to these, remember what they are. So I'm dealing with the sine one, so it looks like this originally, and I'm going to mess around with this point right here because I know it goes through the origin, 0, 0. So we're going to deal with vertical shifts and horizontal. So here the vertical shift is just dictated by this right here, the pi over 2. So I moved pi over 2 up. So from this original equation, I'm going to move pi over 2 up. So it moves up here. The horizontal shift is dictated by, I'm sorry, I should have put this. This is A, this is B, C, and D. And so this is just the D value. This one is going to be told by the C value. Okay, so this is moving 1/2, and because this is a plus sign, that means it moves to the left. So that original point, the one that was right here, I moved it up pi over 2 and then to the left. Okay, so my equation's now going to look like this. Okay. So moving on to this one, guys, I'm dealing with the arc cosine equation. So the arc cosine, it looks like this. So I'm going to rewrite it. This is 2 cosine -1. Take out the 3, x minus 1/3 plus 2, like that. So vertical shift again is just with D, so it moved 2 up, and the horizontal 1/3 to the right. So again, this point I'm going to use I used this one right here. I guess it's a little bit easier to move. So, well, no, we can use this one right here. So this point right here moved 2 up, so this way, move more up. If this is where it was, it moved up, and to the right 1/3, so over here. So my equation now looks like this. Okay, so moving forward, guys, the trig stuff, there's going to be a lot of it on there, and so we're going to need our unit circle, which I have one here. Again, this is not on our formula sheet, so just remember sine is O over H, cosine's A over H, tangent's O over A, and then the other ones, it's the opposite, H over O, H over A over O. Something like that. Okay, so when working these out, again, I'm going to work on 2, and I'll put the other one on there on the actual notes that I post on the classroom. I'm looking at sine of 60. So sines and cosines, these are the easy ones, guys. Looking at the unit circle, I already know the x is, the first number is the x, the second is the y, first one's the cosine, the sine, the a, and the O. So I'm going to 60 degrees, and at 60 degrees is my coordinate, 1/2 and square root of 3 over 2. So at 60 degrees, my coordinate is equal to 1/2 and square root of 3 over 2. I know this is the cosine, this is the sine, Since I'm only concerned with the sign, guys, easy. I don't have to do anything. It's just square root of 3 over 2. And that's my answer. Okay? Like for tangent, cotangent, all the other ones, we're going to have to do a little bit of work. Okay? And so here, 5 pi over 4, so at 5 pi over 4, my coordinate, looking at the unit circle, okay, 5 pi over 4, where is that? Right here. Okay, is negative square root of 2 over 2 over negative square root of 2 over 2. So, if tangent is O over A, and this is A and O, oops, tangent is O over A, I'm going to divide the two numbers. So O is negative square root of 2 over 2, divided by also negative square root of 2 over 2. And here I can see, guys, I could do keep, flip, and change. And I'll go ahead and do it here just so you guys can see. But you're going to see that this is all going to cancel each other out. Okay, so the 2's cancel, square root of the 2 cancel, these cancel. So my answer here is just a 1. Okay, so again, I'm just doing this so that you guys know how to work them out for the other ones. But this is all I would need to do. Keep, flip, change. Here it ends up equaling 1. I won't do this one here, guys, but I will just look at the notes that I post online, just so we can save a little bit of time here. Okay, so next problem. The unit circle here. Again, I have the unit circle here. These problems, what I'm looking for here, okay, I'm going to do this inside part first, and then this one. So when the negative 1 is on the outside, what I'm looking for is what angle does it equal the inside part. So I'm going to solve the inside first. So the cosine pi over cosine pi. So again, at pi, guys, I'm going to look at my cosine, looking at unit circle, x and y, a and o. You see me, cosine, sine. So at pi, my cosine equals negative 1. So here it equals negative 1. So tangent negative 1 of, now I don't want to write cosine pi, I want to write negative 1. So what I'm looking for, at what angle does my tangent equal negative 1? So where, if I divide my a and o, does it equal negative 1? So if I look at this here, again, okay, guys, I know that when I divide these two numbers here, okay, because I'm going to have to, for tangent it's O over A, right? This equals 1. Okay, so I need it to equal negative 1, so this is not the point. This point right here, if I divide these two numbers, it equals negative 1. Square root of 2 over 2 divided by negative square root of 2 over 2 equals negative 1. So one of my angles is 3 pi over 4. And I could also say that over here, if I divide these two numbers, it'll also equal negative 1. So negative square root of 2 over 2 divided by square root of 2 over 2 equals 7 pi over 4. So these are the two angles where my theta will be negative 1 if, actually for the tangent. And that's what I'm asking for. Now for the next ones here, guys, when the negative 1's on the inside, again, you're going to solve the inside part first. This one I have to make a triangle. Okay. So, what I'm going to do here, I know that sine is equal to O over H. And it's also 4 over 5, because that's what I'm getting from the inside part over here. So we're going to make a triangle. We'll say this is theta. That means the O is 4, the H is 5, and we can solve for A. Okay, so if I use the Pythagorean theorem, A squared plus B squared equals C squared. I can solve for this last one here. So okay, and by the time this is done, I'm just subtracting 16. I'll see that the missing side is 3. Okay, so I know that my last side that I'm looking for, my a, is 3. Okay, now I'm going to go back to the original problem. Now that I solved the triangle, I have it over here. Now I can deal with the cosecant part. So cosecant is equal to h over O. And now that I have the triangle solved, I just take my h, which is 5, divided by O, which is 4. This is my final answer here. I should have circled this one too. Okay. So I'm going to split this video into 2, guys. So look for part 2.